I just want to echo, obviously, the excitement at being with a bunch of people in a room talking about seaweed and its cultivation. So again, my name's Emily Buckner. I'm a project manager at PSRF. I'm happy to chat with folks afterwards about our awesome seaweed projects that we have going on. But today, my role as a presenter is to kind of take a step back a bit from that deep dive that we did into water quality issues earlier and kind of provide an overview of all the potential ecosystem effects of in-water seaweed farming. As well as I'm going to speak a bit more about the challenges of developing and managing a new industry in an environment where there's very limited local research and information. But before diving in, I do just want to acknowledge that a lot of the material I'm going to be speaking about today comes from a much larger project with this whole list of folks here that I worked on when I was at UW with NOAA. This paper has been in the works for a long time, is finally in review, and it'll definitely be shared with this whole community once, everything okay? Okay, and it'll be shared with this community as soon as it's available. So I'll be giving kind of it'll be coming all from here. So I'm going to start with the kind of fairly obvious context, which is what everyone's goal for this industry is. And that's to be economically viable, socially acceptable, and ecologically sustainable, if not even beneficial. And I want to recognize that there's a lot of work from a lot of different disciplines that will go into finding that kind of perfect point in the Venn diagram. And for my little bit today, I'm going to be focusing just on that kind of ecological benefits circle, what it might take for us to develop a beneficial farming industry just from an ecological lens. And I also want to note, most of the way me and my co-authors have been approaching this is really thinking about it from a commercial standpoint. So I'm going to use the term industry a fair amount. All right. Okay, so the driving question that I think all of us have, and I know Meg kind of spoke to, is what should be our approach to developing an ecologically sustainable industry in an environment where there's very limited local data or even research on the topic. So first is to look outside of our system and community to identify from the global literature and experts, many of who have been speaking today already, what all of the potential ecological impacts are. And then we can apply that to our local context and native species. So once we've done that, we can then use this best available information to inform initial rules and regulations of the industry, as well as identify research priorities and a monitoring and adaptive management framework for this industry. And as best farming practices are developed, monitoring and assessment can feed back into those initial identified impacts and modify as needed. So thus kind of creating this circle of learning and adapting. Let's see. So my mouse is lost here. So while this is definitely our roadmap for developing this industry, we are more or less kind of still at those beginning stages, right? We're talking about kind of mostly steps 1 and 2, diving into 3 a little bit. And so for the next little bit, I'm going to be mostly speaking about this kind of number 1, so identifying all the potential impacts. And so when I'm sharing the next couple slides, I want folks to hold in their minds this image of a function machine, if anyone remembers that from grade school math, with the idea being that we can identify potential ecological impacts as kind of the inputs into this research and adaptive management machine that will then kind of weigh those impacts, conduct research to assess the validation and the nuances of those impacts, adapt management, and kind of create farming practices which will ultimately yield best farming practices. And so the reason why I really want you all to kind of think, I want to set things up this way, is so you don't see all the potential impacts I'm going to list so much as kind of this pros, cons list, so much as this kind of unweighted and unscaled inputs that we then need to really grapple with as a community. So let's begin by exploring some potential impacts of farming under the umbrella of habitat. So we know that farm seaweed mimics natural seaweed habitat and can provide really similar benefits to native species. But what we don't really know is what is the effects of creating a really ephemeral habitat is, attracting species to only then have that habitat be removed. So that's kind of a big question mark that we need to think about. We also know that forage fish spawn on nearshore aquatic vegetation and could certainly be attracted to cultivated seaweed. So clearly that would be a concern if we have forage fish spawn being removed from the marine environment on a harvested crop. So I'm just going to pause again and just thinking about this framework. So you can kind of see how there's multiple sides of the same coin, right, when we're discussing impacts. And that's why I think it's helpful to think of them more as these inputs into our function machine of research and adaptive management, because we'll start to weigh them against each other, right? These aren't set in stone, these are all potential. Okay, so I'll move a little more quickly now through some other things, but one more slide on habitat. So just like how the crop itself mimics habitat, farm infrastructure, so moorings, ropes, et cetera, also provide habitat and refuge for particularly sessile organisms. However, they also, having ropes in the water and infrastructure poses a real threat to wildlife. So particularly large marine mammals, and it can range everything from disrupting their movement and migration patterns to entanglement risks. We also know that farm infrastructure could be a potential source of marine debris, which is also another source of potential entanglement hazards. So if we move on to consider potential water quality impacts, which was obviously just discussed in depth by some actual experts, not myself, we know that seaweed is really good at extracting nutrients, chemicals, and metals from surrounding water column, as well as absorbing carbon and stabilizing very localized pH, as was discussed there. So certainly very clear benefits, but as mentioned by others already, we have to think about the scale of a farm that it would take to actually really realize those benefits. On the flip side, there's the potential that absorption of all those nutrients, cultivated kelp could maybe be competing with native kelp. And so we also need to kind of consider that on the other hand. Again, scale, though, is going to be a big consideration when thinking about these kind of weighing these pros and cons. So just like seaweed absorbs a lot of carbon and nutrients, it also sheds a lot of carbon and nutrients via detritus, particulates, and dissolved organic material, which I know, as Betsy and Tom like to emphasize, serve as a really great nutrient subsidy to the food web. But on the flip side, there's always that potential that all of that nutrients and particulates could overload the system with material. And that might particularly be an issue if there's kind of poor water exchange and flushing through the farm. There's also some fairly compelling evidence that seaweed farms can influence the local hydrology, dampening wave energy and potentially even serving to protect shorelines from storm surges. But a lot more, I think, investigation needs to go into this. Anytime we have infrastructure in the water disrupting or changing the natural hydrology, we definitely need to have a critical eye to what that impact really is. So moving on to benthic impacts. So it's quite well documented that anchors and moorings can create habitat-forming reefs, though it's also well documented that those same anchors can disturb benthic vegetation, wildlife, and seafloor structures. And then there's also concern that for the submerged vegetation, that a really densely cultivated seaweed crop could shade out any vegetation below it. So finally, it's important to consider the harder to see impacts, such as cultivated kelp populating the environment with reproductive material and influencing wild seaweed genetic diversity, or spreading diseases to native kelp populations. However, it's also kind of important to acknowledge, especially at this step, how the lens that we view the world and kind of our end goals of cultivating seaweed will kind of impact how we're going to be weighing these things, right? So I think I'd be remiss in saying that for some, cultivation techniques may be seen as a restoration tool, either as a way to potentially enhance wild beds or assist in selecting more climate-resilient strains. Both of those were kind of mentioned already today. So that all said, I obviously put a big asterisk here because this is an issue that's going to take a lot of kind of research and deep partnership with resource managers to kind of figure out this balance here. I know there's going to be a whole panel dedicated to this subject at the later today, so I'm going to definitely let the experts who've been thinking about this more deeply discuss this. But I figured I would be remiss if I didn't include this in the list of potential impacts. All right, so I want to now just return back to that framework that I introduced at the beginning, because I just walked through step one pretty quickly. But we walked through step one, which is identifying that kind of whole suite of potential impacts, both positives and negatives. And so then step two is to apply that to our local context and native species. And kind of taking those together and start to weigh which of these impacts maybe we're more concerned about, what should we emphasize more, with the idea that then when we're starting to prioritize research, we can figure out which areas we should kind of start with, right? So my co-authors and I and the folks who've given us a lot of input in this have identified kind of 4 major ecological concerns for this region, which we think should be kind of the first points of emphasis and kind of the areas where farming needs to be the most kind of conservative, right? And so number 1, nobody's surprise at all, is marine mammal entanglement. So first I want to note that there are no documented cases as of now of a marine mammal being entangled in a seaweed farm. But that said, any lines in the water pose a potential threat, and these are highly protected and, as everyone knows, very beloved animals in this region. So we definitely want to emphasize caution here and be super conservative. The second point that we would say is something to really emphasize is this issue of forage fish spawning events. So we would recognize that there's a pretty high likelihood that this could occur. Forage fish are a super important species or group of animals in our system. So we want to make sure we're not negatively impacting them in any way. Oh, let's see if there it is. Okay. The third is this question of benthic disturbance or shading of submerged aquatic vegetation, such as eelgrass. So again, kind of thinking about this region and how important eelgrass is as habitat for all sorts of organisms going forward. So again, we don't want to be negatively impacting eelgrass in any way. And then finally is this issue of influencing wild kelp genetic diversity. And the reason why we wanted to emphasize this so much is mostly because of the big question mark that it poses right now, but also based off of Betsy's talk just now, we know that wild kelp populations are struggling in our region, and so we want to be super thoughtful moving forward to think about how a seaweed farming industry would interact with wild kelp populations. populations. So again, by emphasizing these 4 concerns out of kind of all the potential impacts I listed before, we can stipulate that initial farm design, research, and monitoring should really prioritize mitigating and understanding these risks first. All right, so finally, I want to kind of put all this together and show how that first step of identifying potential ecological impacts plus prioritizing local concerns can help develop initial farming practices, such as where to site a farm. And our paper goes into more depth with some other steps too, harvesting, cultivation, et cetera. But I'll just talk about siting a farm here. So first, you would want to ensure that water quality meets growth requirements for kelp and contaminants. You want to make sure you can grow kelp where you know kelp can grow. You want to make sure your kelp isn't going to be absorbing a ton of nasty stuff in the water that then people can't consume. You also want to ensure that there's adequate water flow through the farm. This is both to make sure your crop has sufficient nutrients for growth, but also so that there aren't that the particulates are being flushed from the system and not potentially overloading it. Though, as noted earlier by Micah, you want to make sure that it's not so much water flow that maybe you're not getting any of those potential benefits of mitigating pH and things like that. So out of concern for native vegetation, farms should minimize any overlap with native aquatic vegetation and could consider being sited in fairly moderate water depth so that it would be so deep it couldn't actually shade anything below it. though you wouldn't want it to be too deep, right? Because we want to avoid marine mammal feeding areas and movement areas as much as possible. So, avoiding siting your farm in an area with a history of forage fish spawning events, as well as known marine mammal feeding areas. I'm thinking of like where the sounders, the gray whales, return year after year after year, especially in the Whidbey Basin. All right, so that's kind of a whirlwind. I know that everyone wants to go on break anyway, so I sped through that. But I'm going to conclude here, and I'm looking forward to either discussion, probably at break, lunch, et cetera. I'm guessing we won't do questions now. But I do just kind of want to take one last second to kind of conclude and just acknowledge that folks at the end of this presentation especially might feel a little maybe unsatisfied, maybe a little frustrated, like there are a lot more questions than answers, like maybe there's not a lot of guidance, maybe that guidance is kind of vague, to be totally honest. And I just wanted to say that I totally understand that, and I feel very similarly often when thinking about these issues. Our paper does go in more depth, so I hope we can give you more information soon. But this also kind of, this is the place that we're in with this industry. We're really at the beginning, and just there's a lot of learning and adapting to be done. So while people may be sitting with some frustrations, I also want to offer the counter perspective, which I try to tell myself when working on this stuff, which is how exciting is it? And Meg said this too, right? It's super cool to be at the beginning of this future industry and be able to guide and develop and direct it to make it the best it can be. So hopefully people can go out on break feeling really more energized and excited about all the opportunities moving forward. So I will just leave the acknowledgement slides up. So many people have contributed their thoughts, their feedback, their ideas to myself and my collaborators. So many of them in this room. So a huge thank you, and I'm sorry this paper has been taking so long. You want questions? Okay. Kate says a few questions are.
A few minutes for questions.
Okay.
Allowed.
Okay.
Right here.
Okay. If people want to.
And Betsy. So,
Great.
Yeah.
Do you want to come up?
Maybe nobody has questions.
It might-
Everybody's ready for break.
They might be.
Don't feel that you
Sorry, I'm
must.
keeping you from break. Hi, thanks, great presentations, can you hear me?
Yes.
Okay. My question, and I love sort of this big picture, Betsy, that you're having us, like, help us envision sort of the bigger picture of kelp beyond structure. I think that's really important. And then I'm gonna get to a more wonky question. But I'm curious with your restoration research, if you're focusing also on sort of the causes of decline in those areas and versus sort of propagation techniques. And if you can talk a little bit about the balance between your restoration research and how it addresses both of those factors?
Yeah, great question. Did everybody hear that? Okay, so the question is, in our restoration, are we also focusing on the causes of the disappearance of kelp forests in those areas or those declines? And it's a really, really good question. And I think that the way that we're pursuing this is that there always have to be parallel pathways, multiple pathways, in terms of trying to understand the drivers and the stressors of decline, as well as testing out whether or not it's possible to do restoration. I think that restoration itself as an action can also often provide really good research opportunities to give you information about conditions in that place. And are conditions such that you can grow a kelp forest from seafloor to sea surface? Are conditions such that you can also be supporting those earlier life stages such that you get natural recruitment? Where are the bottlenecks? Where are the things that aren't working? So it gives us insight into what's working and also can just potentially provide more propagules in the water, because if the decline and disappearance and sinking below a critical threshold of kelp forests as an area is the reason why there's not enough, it can't come back, there aren't enough propagules in the system, then that may be one of the limiting factors, one of the stressors. So it's giving us information, it's giving us a living laboratory in which to try to answer those questions.
We think the mics aren't working, so.
None of them working? Okay. So I'm Phil Black with Confluence Environmental. My question is for Emily, or comment somewhat. You highlighted, I think accurately some of the potential concerns. I think it's important to pass those through the analysis of best management practices, as you suggested with the siting as a clear way to avoid some of the impacts to SAB and field grass, in addition to just highlighting what the concerns are. Because some of those are fairly effectively managed with best management practices. Some of them may not be. And I just wanted to see what your thoughts are and if there are ways to incorporate that into your
Yeah, it's a great question. So that's the second part of our paper does dive into kind of these initial kind of guidance ideas for for farm design that will hopefully incorporate and minimize any of those potential impacts. So there's things that we can do like for forage fish spawn. It's pretty simple. If forage fish spawn on your kelp, you can't harvest it. There's a pretty simple best farming practice. You would work with Fish and Wildlife and kind of coordinate your harvest to be timed to make sure that there was no longer the eggs had hatched, et cetera. So there's some very kind of simple best management practices to mitigate some of these concerns, but others are really challenging. And I think that's where we get that kind of the struggle between a sustainable versus a beneficial industry. And so, we talked a lot about scale of farm. If we wanted to use seaweed cultivation as a way to try and help with eutrophication or mitigate OA, we would need absolutely massive farms to do that. At a large scale. And a massive farm is going to cause problems if we think about entanglement risks or marine spatial use conflicts. And so I think that's where the farm design is tricky, and we really want to emphasize that adaptive management because we're trying to kind of weigh the benefits and the concerns and try and meet in the middle the best we can. So you're right that there are some best farming practices that right off the bat we can just say right now, like the forage fish spawn, like harvesting your whole crop so that you don't allow reproductive material to enter the environment. So there's things we can say off the bat that we think will work, but there's going to be a lot of trial and error in trying to find that sweet spot. So thanks for your question.
Thank you for your presentation. Thanks, Betsy. I was curious about whale entanglement and whether there's any evidence surrounding, floating aquaculture, how animals may be attracted or avoid those areas. Through the growing process of if you have a kelp farm where your biomass is increasing, how would animals be more likely or less likely to avoid those areas?
Before she answers, could you give us your name, please, for the recording?
Yeah, my name is Casey Pruitt, and I'm with the DNR Design.
Casey Pruitt, thank you. And I think this is the last question, right, Meg? Or is there room for one more after this? This is it? Casey, you got the last one.
You asked thanks for ending with a hard question. Yeah, I don't know if we're going to have, Dan, do we have any entanglement folks here from NOAA today to speak on that at all? Okay. So one thing in our paper that we recommend, we did talk with folks from PRD, Protected Resources Division, about recommendations for how to kind of hopefully most minimize an entanglement concern. Most entanglements that happen, especially on the West Coast, are with pot fisheries or loose nets. So usually the issue with entanglement is more really loose lines. For seaweed farming, it's already the practice, but we would emphasize that you'd want really, really taut lines in the water as a way to kind of hopefully not allow entanglement to occur. You can have, really, really intense, I'm thinking like metal lines even. I think your question about like the size of farm, attracting them, was that your kind of a side question?
Yeah, I guess an avoidance, well, you have material growing as, farms
you're going from lines in the water to, biomass increasing, if there'd be any seasonal maybe avoidance, or I don't know.
Yeah, I think it's a great question. I think that would have to be researched. And I think in our, in our recommendations for monitoring, we think that, reporting and monitoring species assemblages around farms is really important, both to kind of get a better sense for how much are we mimicking habitat, creating habitat for forage fish, salmon, et cetera, but also any larger species like marine mammals. It would be really important to kind of note those patterns of interaction. Definitely if there was any actual bad interaction, that would be you'd have to report that. But we definitely would emphasize trying to start getting a sense for those interactions, because I think it's a really interesting question. And yeah, sorry, I don't know.
Thanks, Casey.